Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem related to velocity potential function. In our previous lecture, we have discussed the theory part of this velocity potential function. And here I have taken a question. The question is given, the velocity potential function phi is given by an expression phi equal to minus xy cube by 3 minus x square plus x cube y by 3 plus y square. And here we need to find out the velocity component in the x and y directions, and so that phi represents a possible case of flow. Okay, so let's solve this problem. This is nothing but very simple only. We need to know the equation and we need to know the derivative part. So first what I'll write as the question given, phi equal to this minus x cube by 3 minus x square plus, just write this equation, x cube by 3 plus y square. Okay, so this is the equation given for us for the velocity potential function. Now here what I'll do is we need to find out the velocity component in the x and y direction. So first what I'll do, I know that del phi by del x, I'll do these things. So these things if I do for this particular equation, then what I'll get here, del phi by del x if I do, then I'll get y cube by 3 as usual, derivative of this function. So x will be as usual, it will become, and y cube by 3, that will be constant for that, so it will come out. Now this one will get, minus 2x plus this will get x cube by 3. So that means we'll get here 3 x square y by 3, and this term is nothing, so del phi by del x, you will get this equation. Similarly, this is along the x. Similarly, we need to find out del phi by del y. What I'll get here similarly. So here with respect to y cube I need to consider, so x is constant, it will become out. So that means we can write 3xy square by, as usual 3 it is there, we can write that one. And as usual here x square is there, so that will be not with respect to derivative, will not there, so that is leave it. Now again here you can see only y is there, and here x cube, so x cube by 3 as usual we can write, y will be not there because derivative of y by del y will be cancelled. Now here y square is there, so this one I can write 2y. So this equation I can give equation 1, and second equation, the del phi with respect to y del y, I can write equation 2. So we know that actually the velocity component for u and v, what we have seen in the velocity potential function. So we can write the velocity potential function u equal to, we know that the negative derivative of that function, if you've seen that video you can remember, so the velocity of that will be the negative derivative of the particular direction. So that means the u equal to del phi by del x. So here what we got, just we need to do the minus of this. If minus of this will be there, then we can write that is y cube by 3 minus of minus plus 2x minus 3x square by 2 divided by 3 means we can only write, we can do one thing, just I'll reverse it. Yeah, just I'll write this one, only x square by y, x square y. Okay, so this is the velocity component for y, u in the x direction. In the x direction this is. Now similarly y, what I can write, now y equal to also minus of del phi with respect to y direction, so del y. So here also same thing, minus, I'll just multiply it on that, so that is nothing but 3x y square divided by 3, again 3 will be cancelled, so only y square, xy square minus x cube by 3, and here again it is minus 2y. Okay, if you see here in this, what we did, only we have just derivative of this, that phi is given, the velocity potential function, we just derived this in the x and y component. Nothing we did extra things, equation given for us, so So this is the equation given for us in the question, correct? So for this question, what we did with respect to del x with respect to del y, these two things we did. That means derivative of this function with respect to x and derivative of this function with respect to y. And after that, we know this, the velocity potential function is denoted as u equal to the negative derivative of that particular velocity in the same direction. U in the x direction, y in the y. This is v actually. This is not y. This is v, because we need to find out the velocities u and v in the x and y direction. Velocity component in the x and y direction. So this is the first point. So first point we have completed. Now if you come to the second point what is given? So that the phi represents a possible case of fluid flow. Now possible case of fluid flow, when it is possible? Now when it satisfies the Laplace equation. Okay, when it is satisfy the Laplace equation, then what you can say, the phi will represent the possible flow when it satisfies the Laplace equation. I'll write it here in this side. So second point, let it try to complete in this, if it is possible. It should satisfy the Laplace equation phi. Okay, it should satisfy this. Okay, now for satisfying this one, we know that Laplace equation we can write. So del square phi by del x square plus del square phi by del y square equal to 0. This is only two direction because x and y given, so we are no need to consider for the z. Del square phi by del z square no need to consider, only these two dimensional we can consider it. So in the first and second equation, if you see, already del phi by del x and del phi by del y, it is already given. So here we need to find out this one. So what I'll do, so del of del x with respect to what I can write, del phi by this one. Directly I'll put the value here. Okay, so that means equation of this we need to find out. So del phi by del x already given. So what we'll do, just I'll derivate del phi by, this is del phi, this is not required. Okay, so del square by del x square. So that means the derivative of this total term we need to do. Okay, so that means what we'll get, minus y cube by 3, it is there. So if you derivative of this with respect to x square, so in that nothing will be there, that will be going to be cancelled here. So minus 2x, so 2x derivative of 2x, that means only minus 2 will be there. And here if you see 3x square y by 3 cancel already, so we can write x square y, so we'll get 2xy. Okay, we'll get 2xy. Similarly, if you see, that is del square phi by del y square. So for the second equation, what is there? Del phi by del y. We got this minus 3x square 3 cancel, so minus xy square. So if we derivative of this, similarly we'll get here minus of 2xy, minus of 2xy, 3 cancel. X minus xy square derivative how much? Now x will be taken constant out, so derivative of y square, that is 2y, so minus 2xy. Okay, now similarly this one x part is there, so that is, cannot be derivative of this, so this will be cancelled. And finally see, this is the third term is there, so that is 2y, derivative of 2y, so that will be 2 only. Okay, so this is equation, like means del square phi by del x square, this is del square phi by del y square. So just put this value in this equation. Okay, we know this equation, just put this value in this equation. So what we'll get here, now minus 2 plus 2xy, no need to write implies, only you can write equal. Okay, and plus of this total term, so that means minus 2xy plus 2. If you open this bracket, okay, what will get? Minus 2, this is plus 2 cancel, this is plus 2xy, minus 2xy cancel. So what will get here? Now finally we are going to get 0 here. So that means this 0, what it indicates, that means the Laplace equation, this Laplace equation is satisfied. Okay, this Laplace equation is satisfied. So if it is satisfied, then you can say the velocity potential function, or this phi represents a possible case of fluid flow. That is our motto actually. Okay, so here also in the question what is given, so that the phi represents a possible case of flow. So when it is Laplace equation satisfied that, okay, then we can say there is a possible case of fluid flow. So like this we can solve the problem. I hope you understand how to solve this problem. Only you need to think, we need to remember these two functions u and v, what is the formula for that, and the Laplace equation for to satisfy this possible case of fluid flow. So if you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.